Hi, welcome back to using Terraform with Azure. I'm Matt, and in this video, we're going to walk through creating Terraform modules. A module in Terraform is a container for resources that are used together. You'll often hear the working directory for a Terraform configuration referred to as the root module, since it's also a collection of resources that are used together. That's really all a module is in Terraform. All right, so the first thing I'm going to do is I'm going to switch into the directory for lab 1.8 in the lab files. All files are located in a repository on my GitHub if you'd like to follow along. The link will be in the description below. In this folder, I have a simple Terraform configuration with a main.tf and a versions.tf. When I open main.tf, you can see that I have a simple Terraform configuration which creates a resource group and a storage account. Now, let's say you'll need to create storage accounts inside new resource groups on a regular basis. We could add more resources to this main.tf to accomplish this. However, things could get a little cluttered that way. To clean things up, we're going to wrap all of that into a module that we can use and reuse as many times as we need, and it will produce consistent results. As I mentioned earlier, a module in Terraform is really just a container or folder of resources that are used together. So the first thing we need to do is create a folder for the module. I'm going to create a modules folder in my root module here. I prefer to organize my modules into a modules folder just to make them easier to find. Now, under the modules folder, let's create a folder for our module and call it storage account. Under the storage account module folder, we need to define our Terraform code the same way we do for any other configuration. So let's go ahead and create a main.tf and a versions.tf file under storage account. Under versions.tf, we need to specify a Terraform block along with the required providers. However, this time we're not going to specify a version. To do this, I'm just going to take what I have under the current versions.tf file in my root module. Terraform modules will inherit their provider information from the root module that calls them. Since I'm specifying the version in my root module, there's no need to set a version constraint in this module unless it requires a certain version or versions of the provider. So let's take that out. There also isn't any need to specify any other provider details inside this module. In fact, it's not recommended. Try to rely on module inheritance as often as you can. It will save you from some future headaches. Now that the provider has been set up, let's save versions.tf. Next, we need to set up main.tf. For this demo, I'm just going to copy what I have in my old main.tf into the module. Now, technically, we have a Terraform module that we could call to run this code. However, when creating a module, we need to generalize it so that it can be used multiple times. If I try to call this module in two different configurations, it's going to try to create two resource groups and storage accounts with the same names, causing it to fail. To fix that, let's add a couple input variables which can be used to specify some of the details for the resources at runtime. Under the storage account folder, we're going to create a variables.tf file. Under variables, we're going to create three simple input variables. One for resource group name, a second one for storage account name, and finally, a variable for location. Save variables.tf and head back to main.tf. Now we need to plug the input variables into their corresponding places in the module. Great. Now that I've generalized this module, go ahead and save main.tf. We can go ahead and close the main and variables files for now. Now back in the root module, let's open up main.tf. And we're going to go ahead and delete the resources specified in this file. Now calling a module is similar to specifying a resource to create, but with some differences. The module block consists of the word module followed by a label. This label will be used by the root module to refer to this particular instance of the module. So let's go ahead and label this as storage1. Within the module block, we next need to specify the source. In the previous video, the source was the location of the module in the public Terraform registry. Since this module is local, we need to specify the path or relative path to the module folder that we created earlier. So here, I'll point to the relative path of the storage account folder under modules. Go ahead and save main.tf, and let's go ahead and initialize this configuration. We should see the local storage account module getting initialized for storage1. Okay, we're almost ready to deploy this module, but first we need to specify the values for the input variables that we specified. Now let's save main.tf and run a Terraform plan. Taking a look at the plan summary, we can see that two resources will be created, the resource group and the storage account. Now, if you're wondering why we went through all of that work just to create a couple of resources, let's take a look at the original Terraform configuration versus calling a module. If we look at the code side by side, you can see that moving the resources to a module cut the number of lines of code by about half. You can probably imagine that if this was a larger configuration that spanned several TF files, creating a module could save a lot of time and make things easier to read. Now let's add another call to that same module but with different resource names. Save main.tf and let's try another plan. You'll notice that if you try to run a plan here, Terraform will throw an error because the module for storage2 needs to be initialized now. So let's go ahead and initialize again. You can see that the module for storage2 has now been successfully initialized. Okay, now that the module is set up to create the resources that we need, it's important to make your modules consumable by other configurations or processes. A configuration that calls this module may need to do something with the resources created by the module. To accommodate this, all modules should be set up with outputs that can be consumed once it's been deployed. For the sake of this demo, I'm just going to put the outputs right here in the main.tf file. When creating outputs for a module, try to think about what information another configuration would care about seeing from this module. We have two resources being created here, a resource group and a storage account. So a good place to start would be the ID and names for both of these resources. First, I'll start with the resource group. Now I have two outputs, one for the resource group ID and another for the resource group name. Next, I'll do the same for the storage account. Now there are four outputs that we can use later on in the configuration. So let's go ahead and save and close main.tf from the storage account module. Now let's go ahead and run a plan again. Now Terraform is reporting that it's going to create four resources, two resource groups and two storage accounts. Okay, now that we have the storage module set up for this root module, let's take things a step further. Let's say now that I've created a storage account, I need to also create a storage container for that resource. I'm going to go ahead and put in some sample code that I got from the Azure RM provider documentation after storage2. This is going to be used to create a storage container under the storage account that gets created by the storage2 module. The Azure RM storage container resource requires the name of a storage account as one of its arguments. But you'll notice that there's no longer a storage account resource block in main.tf in the root module, since we moved it into our local module. However, thanks to the outputs that we set up earlier, the process for referencing resources from inside a module is pretty similar to how you would reference everything else. Except here, you'll start with the word module, followed by the name that you specified when you called the module, storage2 in this case. Then, after the next dot, you would reference the output for the storage account name that was configured earlier. The last thing we want to do here is to make sure that this new storage container only gets created after the storage account is deployed from the module. There's technically an implicit dependency here to the storage2 module, but I've found that it's better to just set an explicit dependency when using modules. So let's go ahead and set up a depends on block here. And we're going to specify the storage2 module. Okay, save main.tf here, and let's go ahead and run another plan. Great. Now, you might be wondering why, when we ran this plan, we don't see any of the outputs that we set up for the resource group and storage account. That's because the outputs in the storage account module are exposed to the root module to use, but they will not be exposed to the state or the command line unless we create outputs for them in the root module. Now, if you want to expose the outputs of a module, we can do that right here in the root module as well. Under main.tf in the root module, I'm going to add an output for storage2. And in order to expose the outputs from the module, we just need to reference the module by name, and that will return all of its outputs. If you're just looking for a particular output instead, you can also reference that specific output by name here as well. But for this demo, I'm going to show all outputs. Save main.tf and let's run another plan. Now in the plan summary, we should be able to see the outputs from storage2. Great. Now that was a quick overview on creating a Terraform module that you can use locally. There is some documentation and best practices for writing modules out there, and I'll link to a couple of pages in the description below. I definitely recommend exploring and familiarizing yourself with some of the best practices that are out there. In the next video, we're going to walk through the steps involved in publishing a module to the public Terraform registry, so make sure to check it out. Thanks for watching.